welcome to DoubleG's Garage. One of the questions I keep getting asked is about electrical. How does it work? You know, why do things not work on my VW? What's going on there? So, being as my specialty area as a technician was electrical and electronics, I thought I'd give everybody a series of videos that'll kind of help you repair some of those electrical components on your Volkswagens. So to start with, this first video is going to be basic electrical for your VW. And we're going to talk about how it works. We're going to talk about the theory behind it. And we're just going to get everybody on the same page with basic electrical theory and how important it is to be able to diagnose what's going on with your VW. So to start with, one of the first things that you need to understand is the theory of Ohm's law. Now, don't get me wrong, I'm not a math whiz. I don't expect you to be plugging in numbers in an equation and calculating current flow and amperage and resistance and all that, but it's important to understand the different components that go into electrical theory so that you'll better understand what you're testing, what you're looking at, and what's going on with your VW. So to start with, let's take a look at Ohm's law. Voltage equals I times R. So V equals I times R. So that's the typical way we write Ohm's law out. What does that mean? Well, voltage, pretty easy. That is the electrical pressure that's being applied to your circuit. That's what's pushing the current through your circuit. Now, I know that's kind of hard to wrap your head around, so let me help you. Think of a garden hose, and you've got it hooked up to your spigot, and you turn it on. There is water pressure that's forcing the water through that hose. That spigot that you turned on is a switch that turns on that flow. So it can be applied the same way when we start talking about electrical theory. So you turn on the switch, you turn on the garden hose, the electricity flows through the conductor or the wire, or in the theory of looking at it like a garden hose, the water flows through the hose. Now, if I put a kink in the hose, the flow slows down. If I put resistance into my electrical circuit, my conductor, the flow of electricity slows down. Now, what do we mean by what is resistance? And I'm going to show you a little a picture that shows or illustrates what resistance looks like when we're applying pressure to our electrical circuit. Now, resistance can be a number of things. It can be the load device. It can be what you're trying to operate. So let's keep it simple for this basic electrical, and let's talk about a light bulb. So a light bulb, the resistance that's causing it to actually light up, the filament that's in the bulb, is slowing down your current flow there, and it's consuming the voltage. In a perfect world, and you're applying 12 volts to that 12 volt bulb in your Volkswagen, it should consume all the voltage, and very little voltage should be left over on the ground side. 99.9% should be consumed or used by the component itself. Now, I might have lost you there. What are you talking about? Well, there's other things that are affecting your circuit so it's not perfect. Loose connections, wires that have broken strands in it, just general resistance in the circuit. Anytime you have resistance, it's like having another load device. So I'm going to illustrate this and make it a little bit clearer for you. But if I've got a loose ground, if I've got a corroded ground, if I've got something that causes the current flow to slow down in that circuit, it's the same thing as adding another load device or a second bulb in there, because all of our circuits on our VWs are what we call series circuits. They have one path of the current to flow. Now, V equals I times R, Ohm's law. We have our voltage, our electrical pressure on the circuit. We have our I, which is our amperage or current flow through the circuit. What's R? R is the resistance we were just talking about. So if I can multiply my flow times resistance, it'll tell me what voltage I have. Well, we already know we have 12 volts in a circuit, so I'm usually trying to determine what is my resistance in the circuit or what is my amperage or current flow. Now, to illustrate that, you have fuses in a fuse box that are rated for different amperage or current flow. If we exceed the amount of flow through that circuit, the fuse blows. That's what it's there for. It's a safety component in our circuit. So, if I look at it that way, I'm going to ask a question here. See who's on top of it. If I have a 30 amp fuse, what is it restricting or what is it protecting? Okay, since you can't answer, I'll give it to you. It's protecting the circuit for any amperage or current flow greater than 30 amps. If it gets greater than 30 amps, in most of our wiring that's in our Volkswagens, it could cause the wire to heat up, it could cause the wire to melt, so we want to protect it, so we've got a red 30 amp fuse. Now, we've got other fuses in our fuse box that we can take a look at that are 15 amp. It's going to protect the circuit up to 15 amps. If it gets more current flow than 15 amps, it's going to cut that circuit off. It's going to burn the fuse up. The fuse should burn up before the wire or burn up before the load device or component that we're operating. So, back to Ohm's law. You need to understand the three components that are in there in the theory of Ohm's law so you can understand how to diagnose your circuit. Step number one, we always have to have voltage for the component to operate. So I'm going to test and make sure I've got my 12 volts, or let's just be realistic. Most of our batteries in our VWs when they're charged up are somewhere around 12.5 to 12.6 volts. So I'm going to get my volt ohm meter out, or I could get a test light out and see if it lights up, but it's not going to tell me how much voltage. I want to make sure I've got my minimum voltage around 12.5 volts. So I'm going to test it. I have to have my electrical pressure on the circuit. So always start there. Now, if I was diagnosing, the second thing I'd look at if I didn't have power going to a component, obviously look at that fuse and see if something caused it to blow. But again, I'm testing to make sure I have voltage applied to that circuit. All right, moving along. Current flow. Current has to flow. What's going to cause it to slow down? The resistance in the circuit. So if I've got resistance, the current flow is going to slow down. Something's going to heat up. Something's going to consume voltage. And in other videos, we'll get into things like voltage drop and what's going on there, or power on the ground. Why do I have power on my ground? And so we'll test all that. And what's going to be cool about these videos is I've got a lot of components on the 64 that aren't working. So we're going to walk through how to diagnose and repair some of those. So again, for today, I want to get down to the basics and explain how does this work, what is Ohm's law, what am I testing, what am I looking at on a VW wiring diagram. It's going to be real helpful. So one more thing I want to cover is in order for a circuit, electrical circuit to operate, a series circuit like we're talking about, I have to have the components that we talked about, but I have to have a loop. So in other words, I have to have a power and I have to have a ground. And it's a continuous loop. If I break that loop anywhere, that circuit's not going to operate. So if you look at your battery that's in the back seat of your Volkswagen, you've got a red power wire and you've got a black ground. So simply put, the ground wire is grounding the chassis of the vehicle. We're going to come back to that because it's going to be real important here in a minute. So our ground wire goes to the chassis, typically bolted right there near the battery. Where does that red power lead go? If you've done any work on your VWs lately, I'll show you here where it's going to. Anybody recognize this? Volkswagen starter. So that big red power lead is going right here, coming off your battery, and it's going to the starter solenoid on your starter. And that's a key component in our VWs and our series circuits, because off of this post on the starter, through the rest of the wiring diagram, it actually connects all the way back to the fuse panel that you can see in the trunk area. So this is a key component here, making sure this is tight. Again, making sure your ground wire and your positive lead are in great shape. But this is a key component for diagnosing our electrical system on our VWs. And we'll talk in a minute here, why does my starter drag? Why does it not operate correctly? Why does it just click when I turn the key? Those kind of things are what we're gonna diagnose a little bit further down the road. But power wire, ground wire, making a big loop. And we'll talk about looking at a wiring diagram here in a minute, what I'm talking about with that loop and where does it go to. Okay, as I just mentioned earlier, there's your battery that's mounted under the back seat on your VW. If you look at the left-hand side of the screen here, that is your ground wire, and you can actually see that it's bolted to the chassis of the vehicle. Now, my particular VW doesn't have color-coded cables on there, so of course I added some, not only for identification purposes, but having that red cover over the positive terminal, it will help protect the chances of us shorting it out. But if you look carefully, you'll see that that red cable, or the positive cable, will go through that grommet, which right now is out of place, I need to fix. But it goes through the chassis and it connects to that starter we were just looking at. And that is your main power feed going back to your fuse panel. Let's take another look at the fuse panel and see where does that go. Okay, continuing on. You can see I've got a pointer going to, in this case, this is a 64. Not all of your wiring diagrams for all your VWs will be the same, but they'll be very close, and the theory still works the same way. So we're going to follow along on this 64, which I've actually done an alternator conversion on. So if you look at the red wire that's coming from the right side of the fan shroud, that actually attaches back to that starter post where your positive battery cable is, and it comes to the post on the alternator, and then it runs into the actual wiring harness that feeds back to the fuse panel, which I'll show you in a minute. Now, I'm also going to show and illustrate this on a wiring diagram for a 64 so you can actually trace it out on paper and see what it looks like. I don't know, what do you think? Do I look smarter if I'm wearing my glasses? I don't know. Should I leave them on, leave them off, wear them up here? What should I do?